Okay, let me see if I'm reading this correctly. So the null hypothesis is that the population mean, in which our case it is, I think, okay, so the student says, so that's his claim. That's the null hypothesis. His claim is that the mean raw score is more than 30. But according to this, the null hypothesis is that the population mean, mu, Greek letter mu, is equal, not greater than, equal to a certain claimed value, mu naught. The notation for the null hypothesis is h naught colon. Okay, so our null hypothesis in this case, it seems that it would be mu is equal to 30, not mu is greater than 30. Okay. So then the three possibilities. Okay, so the three possibilities for the alternative hypothesis are mu is not equal to okay, so this is their example here. They're talking about the average minutes that a working mother spends talking to their children. Okay, so in our case, we have mu is, the null hypothesis is his claim is that the mean raw score is more than 30. So the null hypothesis is mu is equal to 30. And then the alternative hypothesis is either of three options. It's either mu is not equal to 30, it's greater than 30, or less than 30. Now, I'm not sure if I'm interpreting that correctly, but that's basically, I think, what's going on here. So this so far is a really good book. I think I'm getting somewhere with this. Okay, so I'm going to send this, and maybe you can take a look at the null hypothesis thing, because basically you're doing a test on and we're using the traditional or classic approach. So you're doing so not doing the p-value approach, we're doing the traditional approach. So we formulate a null and alternative hypothesis. Determine rejection regions, and those are the tails on the sides of your distribution picture. Anyway, the distribution. The rejection regions are the tails on the sides of the distribution. Okay, so then we observe the sample data, compute the test statistic. So in our case, I think what we have is we have 50 people, and mu. Well, in this case, it's not called mu. It's the average basic. Yeah, that thing right there. X bar. Because when you're dealing with when you're talking about a sample versus a population, there's just like slightly different terminology. So lowercase n in this case is 50. Uppercase n, we don't have an uppercase n. I mean, it's actually, because it's you know how exactly how many students you have at the school. That would be the whole population is capital N. Something like the United States population, you can guess at it, I guess. Anyway, so compute the test statistic. So that is that our the mean raw score is 31. Okay, so reject the null hypothesis supporting the alternative. And which is the alternative? The alternative, and this is where I'm kind of confused, is the alternative that the average is less than 30, or it's not more than, well, this is saying the same thing, right? If it's equal to 30, is that still not passing the test? I don't know. So anyway, let me get back to my reading.